How loud can a sound actually get? Not just ear-splitting loud. We are talking about a hard, physical limit, a ceiling baked into the laws of physics itself. Most people assume sound just keeps getting louder the more energy you throw at it. But that is not how it works. There is a point where adding more energy does not make a louder sound. It makes something else entirely. Something far more destructive. Today, we're chasing that limit. Let us start with what sound actually is. Sound is not a thing. It is a disturbance. When an object vibrates, it pushes the air molecules around it. Those molecules bump into their neighbors, which bump into theirs, and a wave of pressure ripples outward in all directions. What we call loudness, measured in decibels, is simply how much those pressure waves compress and expand the air as they pass through. A whisper moves air by a tiny fraction of a millimeter. A jet engine moves it by a lot more. The bigger the pressure swing from the normal air pressure around it, the louder the sound. Every 10 decibels you add means the pressure wave is roughly 3 times more powerful. So 60 decibels is not twice as loud as 30. It is about 1,000 times more powerful. So what happens as you crank the energy higher and higher? The pressure swings get bigger. At around 194 decibels, something strange happens. The low pressure half of the wave, the part where air expands, tries to go below zero, below a perfect vacuum. And here is the thing. You cannot have less than nothing. There is no such thing as negative air pressure. So the wave cannot complete its natural cycle. The trough of the wave literally bottoms out. The mathematics that describe a normal sound wave break down entirely. What you get instead is no longer a wave of alternating high and low pressure moving gently through the air. It is a series of high-pressure pulses hammering in one direction. That is not a sound anymore. That is a shockwave. Sit with that for a moment. So, 194 decibels is the theoretical maximum loudness of a sound in air at sea level. Beyond that, the physics of sound simply do not apply. You are in shockwave territory. To put that in perspective, a space shuttle launch from close range registers around 180 decibels. A nuclear bomb detonation produces a shockwave. It blows past the sound limit entirely. But here is what is wild. That limit is not the same everywhere. It depends on air pressure. At higher altitude, where the air is thinner, the limit is lower. Deep underwater, where pressure is enormous, you could theoretically sustain pressure waves far beyond 194 decibels before they break down. The limit is not about energy. It is about the medium. The air itself is the bottleneck. So what is the loudest sound ever actually recorded in human history? The answer is Krakatoa. August 27, 1883, a volcanic island in the Sunda Strait between Java and Sumatra. The eruption that morning was not just large, it was catastrophic. The entire northern half of the island simply ceased to exist. The explosion was estimated at around 172 decibels, measured 100 miles away. At that distance, that is not the source level. That is what was left of it after traveling 100 miles through open air. The source level was almost certainly beyond any sound that had existed on Earth in recorded history. The pressure wave from Krakatoa was detected on barometers, instruments that measure atmospheric pressure all around the world, not just nearby, all around the world. Weather stations in London, Vienna, Sydney, San Francisco, all of them registered a sharp spike in atmospheric pressure as the shockwave passed. The wave circled the globe, not once, not twice, but 4 times before it finally faded into the background noise of the atmosphere. People in Rodriguez Island, nearly 3,000 miles away, heard what they described as cannon fire coming from the west. They sent out boats to look for ships in distress. There were no ships. What they heard was the pressure wave of an explosion that happened 3,000 miles away and had already bounced off the atmosphere and reflected back again. Think about what that pressure wave actually was as it passed through those cities. Not a sound in the way you experience music or speech. A physical force moving through the atmosphere like a slow, invisible fist. People in Batavia, 100 miles from Krakatoa, were knocked off their feet. Buildings lost their windows. Sailors reported the noise as physically painful, even at distance. This is what happens when sound approaches its physical limit. It stops being something you hear and starts being something that happens to you. At around 150 decibels, a pressure wave ruptures eardrums instantly. At higher levels, it can collapse a lung. The wave does not need your ears at all. It acts directly on your body, your bones, your organs. Krakatoa did not just make a loud noise. It sent a physical disturbance around the planet that moved matter in its path. That is what it means to approach the ceiling. Sound has a ceiling, 194 decibels in open air. Beyond that, you are not making sound louder, you are making a different kind of physics. The universe has rules, and pressure waves in air are bound by them. Krakatoa came closer to that ceiling than almost anything in human history, and left a mark that circled the planet 4 times. Next time you hear a loud sound, spare a thought for the air molecules being squeezed. They are working hard. What should we explore next? If this made you think, subscribe to Wait Why. We drop a new question every week.